Dear students, in this video lecture, we are going to discuss about packet switching networking techniques. In classroom discussion topic 8, we are discussed about the circuit switching network, how the circuit switching network is formed and how it is working, how to find the delay for circuit switching network. So those things we are discussed in the previous video. In this video lecture, we are going to discuss about packet switching techniques. This is a unit 1 last topic, classroom discussion topic 9, packet switching networks. Okay. So we are going to discuss about the lecture outcome of this video. After listening to this video lecture, as a students, you will be develop a packet switch network and demonstrate how the packets are switching in the particular network. If any network is given to you, ask to demonstrate how packets are transmitted in packet switching network. You are able to show that how it is going. After listening this video carefully, then easily you can understand it and you can demonstrate it. So in the classification switcher network, we have circuit switcher network, packet switcher network, message switcher network. Circuit switcher network, it's working in physical layer. In packet switcher network, it may be worked in both the data link layer and network layer. In network layer, mainly it is working as switching the packets. So there is a classification is there, datagram network and virtual circuit network. According to that, we are going to discuss in this lecture. Okay, so what is packet switching? In packet switching, the data communication, we need to send message from one end system to another. If the message is going to pass through packet switcher network, it needs to be divided into packets of fixed or variable size. Okay, so there is no rules for size should be same for all the packets. So as per requirements, it may be fixed size or it may be the variable size. The size of the packet is determined by the network and the governing protocol. According to the rules and regulations, it will be okay. In packet switching, there is no resource allocation for a packets. That means there is no dedicated link will be allocated, and there is no resource will be allocated for switching the packets. This means there is no reserved bandwidth, especially there is no specialized link for transmitting the packets. Okay, even there is no scheduled processing time for each packet. So whenever the packet wants to transmit, as per the on demand, it will be allocated. Okay, the allocation is done on first come first served basis, FCFS basis. When a switch receives the packet, then it will decide where the packet wants to move, how it will be processed, and where the delay is less or where the resource is available. Accordingly, it will be allocated. In a datagram network, each packet is treated independently of all others. Okay. There is no link between first packet and second packet and third packet like that. The packets have independent packets. There is no relationship. Okay. Even if a packet is part of multicasting transmission, the network treats it as through it existing alone. Packet in this approach are referred to as datagrams. Okay. So this approach, whatever we are discussed now, so there is no independent, there is no dependent of previous or existing packets. It will be treated as the independent packets. This approach, in this approach, we can say packet as the datagrams. Okay, so that's why we are saying this datagram network or datagram switching. It is normally done at the network layer. So in this diagram, you just see here this node A, that's a N system node A here, left top corner. in right bottom corner, node X is there. So the A wants to send information or packets to node X. Okay, so what it will do in datagram network, in packet switching, there is no resource will be reserved. Okay, resources are allocated and demand. That means once it is reached the packet here, okay, so here this is the router. Okay, once it is coming here, the router will process the packet and forward it any one of the link which is connected to this. Okay, so in this particular diagram, the router 1, it is forwarded use packet 1 in this link. Then second may be forwarded to this link, and third may be forwarded the same link again, which is sent in packet 1. Then third, last, finally 4 will be used this link. Okay. So, but you see here in the node X, it will be transferred from node to node in a different route. Finally, the packets are arrived, or datagrams are arrived in the destination in this order. First packet is first, and fourth packet is second, third packet is third, and second packet is came late. Okay, so there is no problem for arriving here because the packets are independent. Okay. So whenever the router is forwarding the information, it's maintaining some table. That table name is routing table. Okay, so here in this diagram, we are represent the routing table. In this routing table, what the information is there? Destination address and output port address. So what is the meaning of that? If any destination address, any packet have this destination address, the output port is 1. Okay, if any packets came with this destination address, it will send through port 1. If any packet have destination with the 4150, then it will send the packets to port number 2. Like that, it's maintaining some table. Okay, so if any packet arrived here in this router, it will identify the destination address. It will process according to the destination address. It will forward the packet to which port. That is maintaining in the routing table. A switch in the datagram network uses as a routing table that is based on the destination address. Okay, the routing table mainly based on the destination address. The destination address in the header of a packet in a datagram network remains the same during entire journey of the packet. Okay, so while sending the packet from source to up to reach destination in this network, so whatever the destination address updated by the source, it is remains same till reach the packets to destination. There is no changes of destination address in between the source and destination. Efficiency. Okay, so this is the datagram network. The efficiency of the datagram network is better than the circuit switched network. Resources are allocated only when there are packets to be transferred. Okay, what is the meaning of that? There is no setup phase for finding the route or establishing the circuit or allocating the resource. Okay, so whenever the packet wants to transfer, immediately it will start transfer. The packet once reached to the in between devices, okay, so then it will be processed according to the destination address, it will be forwarded. Compared with this process, this packet switching or datagram switching network is very efficient compared with the circuit network. What is the delay? There may be greater delay in datagram network than a virtual network. So what is the meaning of that? There is no setup phase. Okay, there is no tear down phase. But each packet may experience is to wait at a switch before it is forwarded. What happen? It will reach the switch. Okay, so then it will be processed here. For that, we have to wait some time. Then it will be forwarded some port number, and it again it going and waiting for some other nodes. Okay, so then again the packet will wait here. Like that, it will wait for each and every node. Then it will reach the destination. That delay maybe is there. But in circuit switched network, once the setup is over, the packet may be transmitted directly to source to destination. There is no waiting time for processing of the packets in between the nodes. This diagram clearly represents that initially the transmission time will take for transmitting the packet. So it will reach to the next node. The next node here is there. After it is reaching here, it will process some time, so packet processing time. It is taking some time for identifying destination address and port number and accessing the routing table. For that, it will take some time. That is processing time. So that time will be there in all the nodes. Okay. So here in this node also, here some waiting time is there. After that, it is transmitted. Finally, the total delay equal to 3 transmission. If we are using 2 router, then 3 transmission time, 3 propagation time, and here waiting time 1, here waiting time 2. So the overall delay calculated using the formula. Now we are going to discuss about virtual circuit network. It's a cross between the circuit switched network and datagram network. So both the concept will be approached here. So you see this diagram here, switches are connected and it's like N systems are connected with the switches. But while transmitting the packets, the virtual circuit may be identified. So in the virtual circuit, the switch, the packet have virtual circuit identifier, VCI. Okay, virtual circuit identifier. Here it is there, no? So this may be used for each and every packet. While transmitting the packet, switch will be processed that identifier, accordingly it will processed. In virtual circuit network, 3 phases are there, same like circuit switch network. Setup phase, data transfer phase, and then tear down phase. Okay. So in setup phase, already have 2 processes there, setup request and acknowledgement. Okay. So first initially we know that in circuit switch network we are forming the finding the route or finding the link between the source to destination that will be allocated as dedicated for the packet. Same like methods it will be used. Here you see this diagram, this switch you have port 1, 2, 3 is there, but what it's happened data, this packet data packet have 14 VCI, virtual circuit identifier 14 is there. Once it is reaching to the switch will maintain incoming and outgoing packets information. Okay. So the port 1, this is the port 1, this is the incoming port. Here in this switch, 1 are incoming port, 2 and 3 are outgoing port. So from 1 it is receiving the packet 4 first and then 77 second. So but once it reaches the 14, then what it will do, it will forward it to port 3 with the VCI number 22. Okay. It may be reached in some router. So this may be reached in some routers. Okay. So here it may be changed. So like that, the VCI will be updated in the packet. So it is going towards the source to destination. Okay. So see here for this switch, it is maintaining this label. Incoming port number 1, it is getting the VCI is 14. Then it will forward it to port number 3 with updated VCI 66. Okay. So while it is reaching here, what has happened? Port number 1 VCI is 66. But where it have to be forwarded by this switch? Port number 2 and updated VCI is 22. Okay. So like that it will reach to the destination. So how to update this outgoing port? How we know that? So initially it will go with incoming VCI that will be updated in the routing table. Then it will just forward it to port number 3. Okay, once the packet will be goes out for port number 3. So that will be connected with switch to port number 1. Okay, in port number 1, again it will update that incoming packet VCI is 66. So there is, it will forward the packet to port number 2, but there is no VCI, outgoing VCI. This is not updated. When it will be updated? This is the setup phase. Initially, we are sending the request packet. The request packet will reach the destination here. After that, while it's reaching, this VCI 77 reached to the destination through the acknowledgement packet. This VCI will be updated here, return back 77. Okay, so after 77, what will be there? It will comes again return back. So port number 2, what it is there? Here 22. That 22 will come here. It will update here 22. So then it will come here. It is 66. So that 66 will be updated here. Finally, it will reach the source. So it will identifying and updating the information based on the setup phase. Once the virtual circuit is framed, then packet will be transmitted through that virtual circuit. Okay. In virtual circuit switching, all packets belonging to the same source and destination travel the same path, but the packet may be arrive at the destination with different delays if resource allocation on demand. Okay. So in case what happen, there is no resource allocation previously. While setup phase, it will identify the virtual circuit and it will forward the information through that circuit. It may be some delay may be there while processing the packets. So here what happens, setup phase as usual, same like the circuit switching, tear down phase also is there. But while transmission, there is no processing time here. Okay. So in case processing time is there, then that will be considered here. So end of this lecture, you will be develop a packet switching network and demonstrate how the packets are switching from source to destination. Also, you can identify how the virtual circuit is working, then how the packets are transmitted, how delay is calculated in both packet switching as well as virtual circuit switching. Okay. So now some sample questions for you. List 3 phases of circuit switching network. Okay. So what are the phases are there in the circuit switching? Setup phase, tear down phase, data transfer phase. Sketch the circuit switching network which connect 3 companies which have 3 systems in each company. How it will be work? Okay. So 3 companies are there. Company 1, company 2, company 3. Okay. Like this. So this company wants to connect with this company, then it needs some switch like 8x1 switch. So here 8 systems may be connected, then one link will be connected to these systems, this network like that. Here it may be used for 8x1 switch, 8 input and 1 output link. This link may be connected to this system like this. You can draw the circuit switching. So this is the last topic of the first unit. The next topic from second unit we are going to discuss in the next classroom discussion topic video. Any queries is there, you can post the query, or otherwise you come with the query, we will discuss in the classroom. Thank you very much for listening.